Good evening dear students, welcome to Maths Bridge course. This is your Abhilash Sir. So today we will be discussing the topic of differentiation, which is one of the very high weightage topic when it comes to your competitive exams, be it for JEE mains, JEE advanced, or for your state entrance like KSET, EAP set, all these things, and also for your board exams, that is IPE also, differentiation is having high weightage. So it is very important that you know the concepts very well when it comes to this chapter. Okay, when it comes to this chapter. Now when we talk about differentiation, it comes under the branch of what is that? Calculus. Okay, it comes under the domain of what is that? We call it as calculus. Let me check if I am audible once. Very important that you know the concepts very well when it comes to this chapter. Okay, when it comes to this chapter. Now when we talk about differentiation, it comes under the branch of what is that? Okay, so let us continue. So I was talking that differentiation comes out of the branch of calculus. Now we should know what is calculus. Calculus, it is a branch of mathematics. It's a branch of mathematics. I hope it is visible, which deals with small changes. Which deals with small changes. Which deals with small changes. Very minute changes it deals with. It's a branch of mathematics which deals with small changes. Okay. Now under this comes two important units or two important topics, that is differentiation and integration. Differentiation and integration. Differentiation and integration. Differentiation and integration comes under this. Now if you talk about differentiation, what is differentiation if you talk about? So see, differentiation and integration are opposite to each other. Integration is also called as antiderivative. After differentiating whatever the answer we get, then we call that as derivative. Okay, we call that as what? Derivative. Okay, so see here differentiation, it is about what? It is about studying small changes. What are these changes? What is the meaning of differentiation? What is the geometrical meaning of differentiation? All these things we will be learning in this class. Okay, in tomorrow's class we will be doing some more concepts of differentiation. So first of all, in basic terms, what is differentiation? In basic terms, if I say differentiation, it is nothing but you are separating certain things. Okay, suppose you have a pool of what? Pool of people are there. You are separating them and you are sending them to the respective classes. Okay, that is known as differentiation. And you are, if you are asking all of them to come together and sit at one place, that is called as integration. Integration is summation, differentiation means you are separating them in basic terms. That is the meaning of differentiation. Now, suppose we take real life example. If I say, see here, this is the distance if I am talking about, this is the distance if I am talking about, this is 0, okay, 5 meter, okay, 10 meter, 20 meter, or instead of meter let me take it as kilometer. Let me take it as kilometer. This is 0, this is 5 kilometer, this is 10 kilometer, this is 15 kilometer, this is 20 kilometer. Okay, and let me talk about the time here. This is the time taken. This is 0 seconds. Okay, this is 0 seconds. This is let this be meter only. Then it will be better for you to understand. Let it be meter only. So 5 meter, 10 meter, 15 meter, 20 meter, like this. Let this be 0 seconds. Let this be 5 seconds. Okay, let this be 15 seconds. Let this be 20 seconds. 20 seconds. Now see here. Let there be a car here. Let there be a car here which is moving. Okay, let there be a car here which is moving. Okay, let there be a car here which is moving. Okay. Now if you talk about this, let there be a car here which is moving like this. Let there be a car here which is moving. Okay. So suppose from point A to point B, the distance that is covered by the car, if you want to know, what you will do? Okay, you will find out the distance. For that, you will have the horizontal line. Using that, you will find out that it will move 20 meters in how much second? 20 seconds. Okay, you can take like that. Apart from this, we have one more concept called average speed. Average speed. Average speed means what? Average speed means you will write total distance by total time taken. About this, which you would have already known, you would have studied in your lower classes. Total distance by total time taken. Okay, total distance is what? 20 meter divided by total time taken is 20 seconds. You will write it as what? What is the speed? You will write it as 1 meter per second you will be writing. Okay, 1 meter per second you will be writing. For this entire journey, the average speed is what? 1 meter per second. This is totally fine. But if I ask you, suppose, see here, on this journey, suppose here there is a hump on the road. There is a hump in the road. That means definitely he has to apply the brakes. He or she has to apply the brakes. Okay. So over the entire course of journey, you cannot say there is uniform speed of 1 meter per second. Okay. So here there is little, what is that? Brake. Okay. That means the speed will come down and then again it will accelerate. So to maintain 1 meter per second, again here it has to increase. So here differentiation helps us to find what? Differentiation helps us to find the speed at this point. That means what? If I want the speed at, okay, suppose this is a time, this is 14 seconds. Okay, at the 14 second, what is the speed of the car? At the 14 second, okay, 14 second, speed is what? 14 second speed is what? Okay, not after 14 second, at the 14 second, at that instant, what is the speed if you want to find out? Okay, speed is what? You will use differentiation. You will use what? Differentiation. Okay, you will use what? Differentiation. Okay, differentiation you will use it. So differentiation helps us to know what? Basically differentiation helps us to know rate of change. Okay, rate of change. So see here, it helps us to know rate of change in terms of what? That is also called as instantaneous change. Okay, instantaneous change. Here in this case we call it as instantaneous speed. That is, observe here, the speed at the 14 second. The speed at the 14 second we will be able to find out. Otherwise average speed gives us what? Over the entire course of journey. Okay, how much it has travelled given by how much it has taken the time. If you will get overall speed, that is 1 meter per second. But I don't want that. I want at the 14 second what was the speed. Or if it is at the 16 second, what is the speed? At that particular instant only I want the speed. Okay, at this particular instant I want the speed. Then we need rate of change or instantaneous change. For that we use what? Differentiation. So what is this instantaneous change or rate of change? Here it represents, see here, what is changing? There is change in distance over time. Okay, so if suppose I take distance as a function of x and time as a function of t, we represent it as dx by dt. We represent it change of, what is this? Distance. This is distance over time. Okay, this is dx represents small distance over small time. Small distance over small time. Okay, because we want at the 14 second. Okay, at the 14 second, what is the small distance? That is, it has travelled. So that gives us what? Distance by time gives us instantaneous speed or instantaneous velocity. Instantaneous speed or instantaneous velocity it gives. So this is known as, or we will write it as what? This is known as differentiation, rate of change. So here you can say that, okay, rate of change, let me go to the next page. Okay, we represent it as, suppose we are having the function y, rate of change is denoted by dy by dx. Okay, dy by dx we represent it as, okay, suppose y is a function, it is changing with respect to x. If it is changing with respect to x and if there is very small change, we write it as what? Dy by dx. Okay, dy by dx. And what is this dy by dx? It is the rate of change. Okay, it is what? It is the rate of change. Rate of change. What is this rate of change? Rate of change of a function y. Okay, rate of change of the function y, which is what? Which is a dependent variable. Which is a dependent variable with respect to the independent variable. With respect to what? With respect to independent variable. With respect to independent variable, what is that independent variable? X. Independent variable x. So that is what it says. Rate of change of a function, okay, y, okay, y, which is a dependent variable with respect to independent variable x. So here this is, what is this? This is independent variable. Independent variable. What about this dy? This is a dependent variable. Change of a dependent variable with respect to independent variable, that is what is differentiation, dependent variable. Okay, this is what, friends? This is dependent variable. Is it clear now? Dy by dx. Is it clear now? This is what we call it as dy by dx, that is change of a dependent variable with respect to independent variable. We call it as what? Instantaneous change, that is called as differentiation. So this is the real life application, okay, of differentiation. What do you mean the real spray gold 7317? How long will this take, sir? The class, sir? We will be taking, each class will be taking an average of 45 to 55 minutes, 50 minutes like that. Okay. So up till 22nd we will be having the classes when it comes to this what is it? The bridge course. Please watch the previous sessions also, go to the playlist and watch the previous sessions. If you want more assistance, you can contact on our number. I will draw the institute number, you can contact us. Now, this is what we are having, rate of change. Now, suppose we have a circle. Suppose we have a circle here. Okay, the circle of radius r. Its area is given by what? Its area is given by what? Circle of radius r. Its area is given by pi r square. Its area is given by pi r square. Okay. Now, what happens? There is a change in the radius. The radius has increased. Now, the circle is become like this. This is the circle. Now, this is the circle. Now, what happens? Okay. When there is change in radius, definitely there is change in area. Correct na? So, what is the change in area? Due to the change in radius, that we call it as what? Change in area, that is small change in area, dA by, we will write it as dr. Okay, dA by, we call it as dr. This change in area came because of what? Came because of r. So, this change in area is dependent on change in radius. That's why this dA is what? Change in area with respect to change in radius. So, this dA is what? This dA is dependent. Dependent on what? Dependent on r. Dependent variable. And dr is what? This is independent variable. This is independent variable. This is what? Independent variable, friends. So, this is what? This is the basic meaning of what? Basic meaning of differentiation. This is the basic meaning of what do you mean by differentiation. Now, proceeding further, okay, let us understand what is the geometrical meaning. What is the geometrical meaning of differentiation? What is the geometrical meaning of differentiation? Geometrical meaning. Geometrical meaning of differentiation. Geometrical meaning. Now, see here. Observe carefully. Suppose there is a circle, okay, and there is a chord. There is a chord AB. There is a chord AB. There is a chord AB. These are the endpoints. These are the endpoints. Now, it appears that what happens is this B tends to come near A. This B tends to come near A. Okay. Now, in the same circle, now this B tends to come near A. What will happen is this B will tend to come near A. This B will tend to come near A. This B will tend to come near A. Here it will tend to come. So, this will come close to here. So, what will happen? This entire line will become single point and it is nothing but it will become a tangent. Okay. It will become what? It will become a tangent. It will become a tangent. Okay. It will become a tangent, or simply put, if I draw it again, if B tends towards A, what happens is it will become A and B will overlap. Okay. This is, we will have a single point, you will have a tangent. Okay. You will have a tangent. Now, this tangent, the slope of this tangent, okay, the slope of this tangent is nothing but the slope of the tangent is nothing but the derivative. The slope of the tangent is nothing but the derivative. So, geometrical meaning of derivative is slope of the tangent. Slope of the tangent is nothing but derivative of the function. Slope of the tangent, suppose this circle is given by y is equal to x square plus something square, x square plus y square. Suppose circle is given by y is equal to, let us write it as f of x. This circle is given by. So, slope of the tangent to the curve, slope of tangent to the curve y is equal to f of x is the derivative of this function, slope of the tangent. So, geometrical meaning is what? Slope of the tangent. So, dy by dx also represents what? Also represents slope of the tangent to curve, slope of the tangent to the curve. So, this is the geometrical meaning of the derivative. So, first thing is what? Normally, if you say differentiation, it is nothing but rate of change, it is representing rate of change or instantaneous change in speed, instantaneous change in area, velocity, something like that. Another thing is geometrical meaning is slope of the tangent to the curve. It is what? Slope of the tangent to the given curve. Okay, slope of the tangent to the given curve. Okay, suppose if you take another curve like this, suppose we have a curve like this. Okay, this is given by y is equal to f of x. Okay. Now, what happens is, suppose we have a point here, the slope of the tangent to this curve, okay, or if you have 2 points A and B, okay, and they come towards each other, then we have a point here, then we have a point here. So if you have a tangent like this, okay, this is what represents what, this function y is equal to, this will become what, this will represent dy by dx. This will represent what, dy by dx. This is nothing but slope of the tangent to the curve. Okay, slope of the tangent. It is not the tangent, it is the slope of the tangent. Slope of the tangent to the curve, that is representing dy by dx. This is the geometrical meaning. This is the geometrical meaning, friends. Clear? Now let us move to, before we go to the examples, let us move to certain standard results or standard formulas. Certain standard results and standard formulas. Standard formula, if you talk about for differentiation, so there is a very important formula called d by dx, or before that let me talk about the notation. Notation, when it comes to notations, notations of differentiation. Okay, notations are what, dy by dx. First thing I told you, differentiation will represent it as what, dy by dx. It can also be represented as, okay, it can also be represented as y dash. You know, if f of x is given, it can also be represented as f dash of x. It can also be represented as d by dx, okay, of some function. So let that function be f of x, d by dx of f of x. These are all the various notations we use, which are nothing but one and the same. That is, you are differentiating. You are nothing but differentiating. There is double derivative also. All these things we will be discussing in the upcoming class. First, you should know what is the single order derivative or the first order derivative, that is differentiation. Now proceeding, standard formula. So see here, it is not just that you have to by heart, it is you have to understand conceptually why these formulas are coming, how it is getting out to be the what it is, okay, how it is getting out to be what it is. That is, if I am writing d by dx of x to the power of n, this is nothing but equal to n times x to the power of n minus 1. Okay, this is nothing but equal to n times x to the power of n minus 1. Okay, similarly, if I write d by dx, second one, if I write d by dx of constant, d by dx of some constant, d by dx of some constant, if I write, please observe, d by dx, I am differentiating some function with respect to x. So if I write d by dx of some constant, this is always equal to 0. d by dx of some constant, this is always equal to 0. Okay, this is always equal to 0. Now see here, I told you d by dx of x to the power of n is equal to n times x to the power of n minus 1. Now let us take some example. D by dx of x square, if I take, okay, let us do some illustration here. D by dx of x square, if I take, what happens here, d by dx of x square if I take, so n is what here, n is 2, so the formula will become, so 2 times x to the power of 2 minus 1, that is nothing but equal to 2x. So we are getting what, 2x. Why you are getting d by dx of x square is equal to 2x? Let me illustrate now. Let us take since x square is there, we have to take, let us take square is there, no, x power 2, that is nothing but square. So let us take the figure which is having a square. Okay, let us take a figure which is having a square. So see here, if you take a square here, I think it is rectangle, let us take. Okay, let us take this one. Okay, if you take this figure, so observe carefully, if you are taking this figure, now let us take each side to be of the side length x. This is x, this is also x, and this will also be x. Now suppose there is a small change in the length, there is a small change in this x. Okay, suppose there is an increase of length, there is small change in x, the small change will represent it as dx. This side also it is increasing, and also this side also it is increasing by how much? Some length dx. Okay, some length dx. So let us represent it here. It is increasing like this. Okay, it is increasing like this, and it is increasing like this here. It is increasing like this here. Okay, it is increasing like this here. Okay, it is increasing like this here. Now we know that area of the square is given by what, friends? Area of the square is given by x into x. Okay, x into x. Now we are having x into dx. Okay, we are having the new areas that we are having here. See here, we are having new areas. Okay, if I write d by dx of x square, if I write, see, I should write the new areas that are there. New areas, what are those areas? See here, these are the new areas I am having. These are the new areas. Okay, these are the new areas I am having. New areas I am having. Now if I see here, okay, if I see here, how many areas I am having here? How many new areas? 1, 2 and 3. 1, 2 and 3. So observe carefully, this will be dx, this will be dx into dx. Okay, if I look at this, observe carefully, what will this become? This will become equal to 1 what we are having dx into x. One is what x into dx. Another one is what here also it is x into dx. See x into dx, this figure. Area 1 is what? Area 1 is x into dx. Area 2 is this box, that is also this. See, look at this horizontal line, that is x, and this vertical line, that is dx. So this will also become x into dx. Now what about this? This one, see this small box, dx into dx. It will become what? Dx into dx. Plus dx into dx is what? Dx whole square. Now this dx is very small, that square itself, suppose dx is 0.01, the square will become what? 0.001. Okay, it will be very small, this is very small, we will ignore it or we will neglect it. Now what we are having? We are left with d by dx is equal to what? D by dx, x square is nothing but equal to x dx plus x dx. So that is nothing but equal to what? 2 times x. Okay, 2 times x. Okay, dx we are writing because we are writing it here. So if I send dx below, dx below, it will become d by dx of x square. So we got the value as what? 2x. Okay, so d by dx of x square is what? 2x. This is the actual illustration that I showed how d by dx of x square is becoming 2x. Clear friends? This will not get anywhere. Why it is coming? You don't have to by heart. Now you understood why it is coming 2x. So similarly, if I write some other things like some other formula based on d by dx of x to the power of n. Based on d by dx of x to the power of n formula, if we write, observe carefully, based on the formula d by dx of x to the power of n, we can derive various other things, various other important results. So what is the formula that we have? D by dx of x to the power of n. Okay, we have what? N times x to the power of n minus 1. So observe carefully, if I have d by dx of x square, it became what? 2x. If I have x cube, it will become what? 3x square. It will become what? 3x square. I don't want you to by heart the formula. See here, what is happening? 3 is coming down, it is reducing by 1, power is reducing by 1. So if I write x to the power of 4, what will happen? 4 will come down, x to the power of 3. If I write x to the, this will become like this. If I write x to the power of 5, 5 will come down, it will become x to the power of 4. If I write x to the power of 6, 6 will come down, it will become x to the power of 5. So similarly, if I write x to the power of 100, what will happen? You can write 100 will come down, it will become x to the power of 99. If I write x to the power of 1000, what will happen? It will become 1000 will come down, it will become x to the power of 999. Like this, the formula is like this. Okay, so this is the result that you should know. So directly you should be able to know this. Don't have to by heart the formula. You don't have to by heart the formulas, friends. Okay, now see here, next thing. Okay, when it comes to like this, you can do it. Okay, now what happens if there is a reciprocal? If you are having a reciprocal, how to do? That is, I mean to say, suppose we are having, what is the result that we have? D by dx of x to the power of n is nothing but equal to n times x to the power of n minus 1. Suppose we are having d by dx of 1 by x. D by dx of 1 by x is there. So it is not of the form x to the power of n. So we have to make it, we have to modify it. So d by dx of, I can write it as what? X to the power of minus n, because we know that 1 by a can be written as a to the power of minus 1. Correct? No, this powers. Okay, law of exponents. This is what the meaning we can do. So x to the power of minus 1. So I can write this as what? Minus 1 will come down, x to the power of minus 1, minus 1. So this will become what? Minus 1, x to the power of minus 2. Or I can write it as what? Minus 1. If I bring x to the power of minus 2 below, this will become x to the power of 2. So this is what I got. Now let me try for d by dx of, let me see a pattern, d by dx of x square. D by dx of x square, I can write it as what? D by dx of x to the power of minus 2. So this will become what? Minus 2, x to the power of minus 2, minus 1. So I will get what? Minus 2, x to the power of minus 3. So that is nothing but equal to minus 2 by x to the power of 3. Minus 2 by x to the power of 6. So see here, if it is 1 by x, it is becoming this power 1. X is having power 1, this is going up. So minus 1 is coming, and below you are adding 1. So minus 1 by x square. If it is 1 by x square, this 2 power 2 is going up, that is minus 2 it is becoming. For this 2 you are adding 1. So it is become x cube. So simply put, I can write it as 1 by x square, 1 by x cube. Similarly, if I put 1 by x to the power of 99, or if I put 1 by x to the power of 1000, okay, what is the derivative? 1 by x means here power is what? 1. So minus 1 by this denominator you are adding by 1. Okay, denominator power 1 plus 1, this will become 2. So this one derivative is what? This will become minus 2 will go up. This minus 2 will go up by what will happen? 2 will become what? Plus 1. 2 plus 1, this will become 3. So see here, 1 by, this is 1 by x cube, minus 3 by what will happen? 3 to plus 1. This denominator is 3 plus 1, this will become plus 4. Okay, this will become what? Minus 99 by x power 99 plus 1, that is 100. Now see here, this will become what? This will become minus 1000 divided by x, 1000 plus 1, that is nothing but 1001. 1001. This is what we will have, friends. This is what we will be having. So this is how we can have the various formulas. Just by based on this formula you can derive all this. So this one you can remember, okay, how we are getting. Now similar to this, if you are having d by dx of root x, it is nothing but equal to 1 by 2 root x. You should remember this formula. D by dx of root x is what? 1 by 2 root x. Similar to this we can derive, okay. D by dx of root x is what? 1 by 2 root x. D by dx of root x is what? 1 by 2 root x. Now let us see some important results. So first thing what we told, d by dx of x to the power of n, let me write at one place, is nothing but equal to n times x to the power of n minus 1. Second is what? D by dx of some constant k is equal to 0. Next what we are having? D by dx of, if I write e power x exponents, that is e power x itself. Fourth one we are having d by dx of, write everything at one place, it will be useful for you. A power x is nothing but a power x into log a. You have to remember this, a power x into log a. Now d by dx of if I write, okay, d by dx of if I write log mod x to the base, nothing is there, base means it is nothing but e. So this will become 1 by x, 1 by x, this will become what? 1 by x, friends. Okay. Next if you are having d by dx of if you are having log mod x to the base a, if you are having, okay, to the base a if you are having, this will become what? 1 by x into log e to the base a, into log e to the base a, it will become log e to the base a. If it is ln x also, it will become 1 by x, natural log. Okay. Next further, okay, further if you see, I told you d by dx of root x is nothing but equal to 1 by 2 root x. Similarly if I say what I got here, this if I generalize and write it, if I write d by dx of 1 by x to the power of n, I can write it as what? Minus 1 by x to the power of n plus 1. These very important results, highly important result this one, okay, highly important result. Now let us write derivatives of trigonometric functions. If I write derivatives of trigonometric functions, what are the things that we have? Derivative of 6 trigonometric functions sin x, derivative of sin x is what? Cos x, derivative of cos x is what? Minus sin x, derivative of 11th one, derivative of tan x, derivative of tan x is secant square x, d by dx of cot x is what? Minus cosecant square x, okay, minus cosecant square x. If I write here further, what is this? This is 10, 11, 12, this is 13, d by dx of secant x is nothing but equal to secant x tan x, d by dx of 14th one, d by dx of cosecant x is nothing but equal to minus cosecant x cot x, okay, minus cosecant x cot x. Now see here how to remember this. So when we talk about trigonometric functions, sin will become to its complementary cos, cos will become sin x, tan x, secant square x, cot x, cosecant square x, that identity you should know, trigonometric identities. Secant x is tan x, cosecant x is minus cosecant x cot x. Now see here, I will tell you a trick here, see how to remember. If it is starting with always, if it is starting with c, we are having minus. Here also see it is starting with c, we are having minus. It is starting with c, we are having minus. So wherever it is starting with c, we are getting the minus sign. Like this you can remember where to put the minus sign. Clear, friends? Okay. Now let us see some example questions based on this. And let us solve them. Okay, and let us solve these questions. They have given differentiate 2x to the power of 8 minus 3 into e power x with respect to x. So that means they have given y is equal to 2x to the power of 8 minus 3 into e power x. This is what is given. You have to differentiate means dy by dx, I should write it with respect to x, means this is what 2 into what is this, x power 8 means I should write what, into 8 to the power of 8 into x to the power of 8 minus 1, that is 7, minus 3 into e power x, differential of e power x is what, e power x only. Now further I can write this as what, 2 into 8 is what, 16, x power 7 minus 3 into e power x, that's all, final answer. Simple, very simple. This is how you will differentiate it. Next one, differentiate 5 sin x minus 9 cos x plus k with respect to x. So here they have given a function, let us take this as y is equal to 5 sin x plus 9 cos x plus k. So see here, sin x derivative is cos x is minus sin x, starting with c, so minus should come. Derivative of k, that is nothing but constant, any constant, 2, 3, 4, any constant if it is there independently, then it will become 0. So dy by dx will be equal to what? 5 times, this is sin x is what? Derivative of sin x is what? Cos x. This is what? 9 times, derivative of cos x is what? Minus sin x, I will write sin x here, I will write minus here. So derivative of this is what? Plus k, that is plus 0. So this will be the answer, friends. This will be the answer. You can ignore 0 or you can write with this. This is plus 0 because derivative of constant is 0. Derivative of constant is 0. Now look at this function. They were given, what is this? Exponential functions. So before this, see here, okay, y is equal to, they were given e power x log a plus e power a log x plus e power a log a. This is what they have given. Now further I can simplify this. We know that e power log x, okay, e power log x, so e power anything. So what will happen? This and this will, what will happen? E power log x will always give us to the base e. What will happen? This, everything will be removed, only what is there we will get it here. Okay, only what is there, on simplifying e power log it log to the base e, only x we will have. So similarly, if I simplify this, I can write it as what? Y is equal to e power log a to the power of x, okay, log a to the power of x plus e power log x to the power of a. Why I am writing this? We know that, okay, m times log n is nothing but equal to log n to the power of m. So this is the identity we are using, properties of logarithm. So this is what? Plus e power, what is this? I can write e power, I can write this as what? I can write this as log a to the power of a. Now this will become what? This will become to the base e, to the base e, to the base e. So this will become, as per this property, y will become equal to what? A power x. This will become equal to what? X power a. This will become equal to what? A power a. Now let us differentiate this dy by dx. Dy by dx of a power x is what? A power x log a. A power x log a plus, what is this we are having? X power a, x power n. Instead of n we are having a. So this will become what? A into x power a minus 1 plus a power a. A power is what? This is nothing but constant. This is nothing but what? Constant. So derivative of constant is what? 0. So dy by dx we will have was, we will have as what? A power x log a plus a into x power a minus 1. This is the final answer, friends. This is the derivative, we will get it. This is the derivative, this is how we will get it. Clear, friends? This is how we will get it. This property is important. So we will get whatever is in the log of something, whatever is there, that we should write it. Okay, and here this property we should know. M times log n is nothing but equal to log n to the power of m. Okay, all right. Let us move to the next one. Okay, they have given a question. Okay, all right, they have given a question. This is a question from some examination. They are telling. So if f of x is equal to 1 plus x square by 2 up to x to the power of n, x to the power of 100 by 100, then f of 1 is equal to what? Okay, then f of 1 is equal to what? Actually this should be, the question should have been, this should be f dash of 1, then f dash of 1 is equal to 1. What mistake you will do? You will try to put f of 1, you will put one value again, for x you will put 1, then you will try to find f of 1, then it will always become equal to 0. First what you should do here, first thing what you should do is you should differentiate. Okay, so I will find what? F dash of x. F dash of x is equal to what? Derivative of x is, derivative of 1 is 0. So remove that, no need to worry. Derivative of x is what? 1. Derivative of x square is what? 2x by 2 is there. Similarly here what will be there? X square by 2 means here it will be x cube by 3. Correct now? So I can write it as what? 3x square by 3. It will get cancelled. Until last term is what? 100 into x power 99 by what is that? By 100. This is what I will be having. 100 cancels, 3 cancels, 2 cancels. I will be having what? F dash of x is nothing but equal to 1 plus x square plus, it will go on up till x power 99. Okay, so f dash of 1 I want. 1 means this will become, wherever x is there I should put 1. 1 plus, this is 1 square is 1 only, it will go on up till 1 power 99. So like this, how many ones we will have? 100 ones. 100 ones means f dash of 1 will become equal to what? It will become equal to 100. It will become equal to 100. It will become equal to 100. So what is the answer? That is option B is the right answer, friends. Option B, 100 is the apt answer for this question. Okay, next thing. Next we will study something called chain rule of differentiation. Chain rule of differentiation. What is this? Chain rule of differentiation. chain rule of differentiation. Chain rule of differentiation. See, some of you or your elder ones, brothers or your parents or whoever, they would have played some game in the keypad mobile, that is called the snakes game, okay, where the snake will go on eating, go on moving till it finds that food, okay, it will move on like this, all these ways it moves to get that food, okay. Like that you have to differentiate till the last term, okay. First, see, you will be having f of h of m of n of, okay, l of, okay, x, okay. You have to differentiate from outside, so you have to find f dash, then you will find h dash, then you will find m dash, then you will find n dash, this is what differentiating, then you will find l dash, then you will find derivative of x is what 1, okay. So you will find up till l dash of x, you will find up till l dash of x. So basically I mean to say, from outside to inside you have to differentiate till the last term. So what does it mean? This is called chain rule of differentiation. So for this, let us do some example questions. So given y is equal to tan of e power cos x, tan of e power cos x. Outside what we are having? Tan, okay, dy by dx, dy by dx of tan is what? Derivative of tan is what? Forget about this. Derivative of tan is what? Secant square. Secant square. Inside what is there? E power cos x. Okay. Now tan is differentiated. Inside you come e power cos x. Okay, e power cos x. So e power anything is e power that only. E power cos x only. E power cos x only. So this is done. So this is done and this is done. Now we have to differentiate this. Okay. E power cos x is there. Derivative of cos x is what? Minus sin x. So this will be the answer. This will be the answer. See, from outside to inside, tan e power then cos x. So like this, from outside to inside we are going and differentiating completely. So here x is also there, derivative of x is what? 1. So we are not writing 1 into something is that something value only will remain as it is. Now see here, look at this question they have given. Okay, let me write it here. They have given y is equal to cos cube ln x. Y is equal to cos cube ln x. Now how to do? Now how to do? Okay, here power is there. Power is there. Then how to do? Okay, power is given. Then how to do this question? So you have to understand the power is most powerful. Power is most powerful. Power is most powerful. So we have to give priority to the power itself. Power is most powerful. So you can write this as what? Y is equal to cos cube log x. I can write it as what? Cos log x whole cube I can write it. Whole cube I can write it. So this dy by dx is nothing but of the form x cube, correct na? X cube means it will become what? 3x square. So same way I can write this as what? 3 into cos ln x whole square, cos ln x whole square. So cos ln x whole square you will have, okay, this is what you will be having, cos ln x whole square. Now going from outside to inside, derivative of cos is what? Minus sin. So minus sin ln x. Okay, now cos is done, inside is there, inside what is there? Ln x. Derivative of ln x is what? 1 by x, and derivative of x is what? X is nothing but 1. So we will write it as what? 1. So this is the final answer, friends. So this is the final answer we are having. This itself is the final answer that we are having. So this is the chain rule. This is the chain rule of differentiation. Now look at this, they have given if y is equal to sin log x, sin ln x, find dy by dx. Here again we have to apply the chain rule, dy by dx. From outside to inside, derivative of sin is what? Cos ln x, cos ln x. Now derivative of ln x is what? I told you derivative of ln x is 1 by x. This will become what? Multiplied by 1 by x. Derivative of x is what? 1. So no need to write 1, keep it as it is. So this will be the answer, friends. One step you will get the answer. Clear, friends? This is how we can do the chain rule of differentiation. You have to keep this in mind. Students go wrong while applying chain rule. So you have to do it up till the last function. Look at this one. They were given if y is equal to log of cos e power x, then dy by dx is equal to what? Okay, what is the function that they were given? Y is equal to log of cos e power x dy by dx. So first tell me log of something. Log of x is what? Log of x is, we will write it as what? 1 by x. So here x is what? Cos of e power x. We will write it as what? 1 by cos of e power x. Now we are having cos of something. Derivative of cos x is what? We will write it as what? Minus sin x. So cos of something is what? Minus sin e power x. Okay, minus sin e power x. Sin e power x we are having. So sin e power x is done. Outside cos is done. Now inside derivative of e power x is what? E power x itself. So we will write what? Into e power x. Into e power x. Now this if I simplify, I am having what? E power x into what is this I am having? Okay, minus, let me write outside, minus e power x into sin of e power x by cos of e power x. Sin by cos is what? If you see this, sin by cos is what? Tan. So I can write this as what? Minus e power x into tan of e power x. This is the final answer we are having. So what is the option we are having? That is option D, minus e power x into tan of e power x. Okay, minus e power x into tan of e power x. This is the final answer, friends. So we can simplify like this. We can simplify like this. Now we have chain rule is done. Now we will do some another rule called excuse me that is called quotient rule. Not quotient rule, let us do the product rule. Product rule of differentiation. Product rule of differentiation. Now basics of differentiation is done. I am talking about the methods of differentiation. So first is what? Product rule. Suppose we have a function. Suppose there are two functions u and v. U and v are functions of x. Suppose we are having two functions u and v. We are having, okay, we are having two functions u and v. If you want to find d of u by u into v of dx. Okay. So if this product rule means the functions are product of each other. The functions are product of each other. Suppose I say x sin x. So x is one function, sin x is also one function. How to do here? So first what you will do? You will find u dash. U dash means what? Du by dx. You will find what? Du by dx, first function, differentiation of first function into second function, keep it as it is, plus, it will always be plus, first function keep it as it is. First function is what? U into differentiation of second function, du by dx, dv by dx, or in simple terms, du by dx I told you what? Notations are what? Notation dy by dx I can also write it as y dash. Similarly, du by dx I can also write it as u dash v plus u v dash. So first function differentiation, second function keep it as it is, first function keep it as it is, second function differentiation. This is called the chain rule, or not the chain rule, this is called the product rule, friends. This is called the product rule. Suppose I take a function, okay, let me take x sin x is there, okay, d by dx of x sin x is given. So what we can do? Let this be u, let this be v. So du by dx, derivative of x is what? 1 into sin x, plus the derivative of x I should keep as it is, second function I should differentiate, x into derivative of sin x is what? Cos x. So this is the answer we will have. This is the answer we will be having when it comes to UV rule. This is also called UV rule. This is also called as what? UV rule. That is product rule, that is also called as U by UV rule. Quotient rule is also called as U by V rule. So let us see some examples of UV rule. So here they are given f of x is equal to x tan x. We have to find what? F dash of x, or we have to find dy by dx. So first function u and v. You will write what? U dash v plus u v dash. U dash is what? Derivative of x is what? 1. Tan x keep it as it is, plus u keep it as it is. U is what here, friends? U is x. U is what? X. Derivative of tan x is what? Secant square x. Secant square x. So this is what? Secant square x. Now we are having f of x is equal to e power log x into log x. So further I can simplify this e power log x to the base. I told you this entire thing I can remove. I can write only x. So f of x I can write it as x log x. F of x I can write it as what? X log x. Now this is u, this is v. Okay, this is u, this is v. Now we have to differentiate this. Just a minute. Now we have to differentiate this. This is u. So I will write it as what? U dash v plus second function I will keep it as it is. First function I will keep it as it is. I will differentiate second function. So this will become out f dash of. Once you start differentiation, you should write it as what? F dash of x. So derivative of x is what? 1. V keep it as it is, 1 into log x, plus x you keep it as it is. Derivative of log x is what? 1 by x. Okay, x cancel. I will have what? I will have answer as what? Log x plus 1. This will be the answer. F dash of x is equal to what? Log x plus 1. F dash of x will be equal to log x plus 1. This is the answer, friends. Okay, let us see some more questions if it is there. Okay, next we will study. Now we studied what? First we studied chain rule. When coming to methods of differentiation, first we studied what is that? Chain rule. Next we studied what? The product rule, that is UV rule. Now we will study the quotient rule, which is also called as U by V rule. Which is also called as U by V rule. Now we will study the quotient rule. So when the functions are product of each other, we will apply UV rule. When the functions are what? It is of the form f of x by j of x. They are rational functions, or if it is in the form of fractions, that is numerator by denominator. If it is there, you will apply what? Quotient rule. You will apply quotient rule. Quotient rule, it is also called as u by v rule. U by v rule. Suppose you have to find d by dx of u by v. What you will do is, first thing is what? Denominator v, you will write it as v square. Okay, then v keep it as it is. You differentiate. You should always keep v first thing. You should keep it as it is. V into, you will write it as what? U dash. You will not write u dash v. You will not write u into v dash. You will keep it as what? V into u dash. V denominator keep it as it is. Make it square, v square. Then keep v as it is. Then u dash. Then you will write what? U into v dash. You keep it as it is. You do v dash. But here in quotient, it will be minus. This is the formula, friends. Suppose we take an example, d by dx of sin x by x. D by dx of sin x by x. Here u is sin x, v is x. So you will keep the denominator as it is. This will become what? X square. X into, this is what? V into u dash minus u into v dash. So v, keep it as it is. V is x. Derivative of sin x is what? Cos x minus u is what? Sin x. Keep it as it is. Sin x into derivative of x is what? 1. So this is the answer, friends. This is the answer. You are applying what? The quotient rule. You are applying the quotient rule. So let us see some examples on quotient rule. They have given y is equal to x power 5 by e power x plus 2. Y is equal to x power 5 by e power x plus 2. So here u, this is u, this is v. What is the formula that we have? V square, denominator v into u dash minus u into v dash. So dy by dx will become what? Dy by dx will become, so denominator keep it as it is, that is e power x plus 2 whole square. Next you will write what? Denominator keep it as it is, e power x plus 2. Derivative of x power 5 is what? 5 into x power 4. That is what you are applying. D by dx of x to the power of n formula. You are applying, minus, keep this u as it is, that is what? X power 5 into derivative of this is what? E power x. Derivative of e power x is e power x plus derivative of 2 is constant 0. We will have this. So finally it will become what? E power x plus 2 into 5 into x power 4 minus x power 5 into e power x, because what will happen? This 0 will not be there. Okay, because 0 you can remove it. Okay, e power x you can keep it, just e power x divided by e power x plus 2 whole square. This is basic. Okay, this is basic. Further you can simplify, that is enough. Dy by dx you can write it like this. Clear? I hope you are getting it. You are getting the concepts. So we started with what is differentiation. We studied what is that we studied? We studied the basic meaning or the basic definition of differentiation. It comes under the branch of calculus of mathematics. Calculus is the study of small changes. There comes differentiation and integration. I told you what they mean in basic terms. So differentiation has two meanings. One is instantaneous change, rate of change or instantaneous change. Another one, it is also representing geometrically, it is also representing the slope of the tangent to the curve. Okay, and we studied various results. Okay, various results of differentiation, and I also generalized certain formulas, and we studied various methods of differentiation. First is the chain rule. Okay, then we studied UV rule, that is the product rule. Now we studied the quotient rule, that is u by v rule. Now let us see one more question on u by v rule, that is you should do dy by dx of this. So denominator keep it as it is, sin x whole square. This sin x you keep it as it is. This derivative of e power x is e power x minus e power x, keep it as it is. Derivative of sin x is what? Cos x. This is the final answer, friends. Okay, this is how we can solve this question. Okay, I will give some questions for homework which you want to practice. So y is equal to, I have given x into tan cube x. This is one question. You should apply what? U into v rule, and also you should apply chain rule here. Okay, next question I will give for homework is y is equal to sin x by tan x. Please do these questions and put the answers in the, definitely you must put the answer in the comment section, friends. Please put the answers in the comment section. I will go through it. Okay, if you are facing any difficulty, put it in the comment section. Alright friends, thank you. I will wind up now. Let's meet in the tomorrow session where we are discussing some more concepts of what is a differentiation. Clear? Thank you. Take care.